Hello, Professor Deb here. Welcome to Technical Mathematics. This video lecture is to talk about phase shift graphs. It is recommended that you view prior to this the video on sine and cosine graphs. We're going to pick up where that video left off. At any time, feel free to pause or stop or replay any part of the video for a better understanding of the material. Let's get started. Okay, this is the equation format for sine and cosine graphs that you should be familiar with, except in this case we are adding a phase shift. This C value in the parentheses means that we are adding, or we have, a phase shift. Let me remind you that the A stands for the amplitude, the B, or the number in front of the X, has to do with figuring out the period, and then we have our sine and our cosine graphs. Notice they're the same nomenclature, they're just sine or cosine. Okay. What we're going to do, let's say that the phase shift is a negative C. So it's a negative of this number. If this happens to be a negative number, it still remains negative C, which puts it as a positive, divided by B, which is the number before the X. Okay, now we pretty much know that a sine graph starts at the 0, 0 point, and a cosine graph starts at the maximum amplitude and minimum amplitude. So that reviews that part of the material. We want to start talking about how the phase shift affects it. First, let's write an equation. Y equals 4 sine x. Now we realize we have no number in front of there, so this is just simply an equation for a regular sine graph without a phase shift. And let's see what that looks like. Remember, we put our amplitude here on the graph. We start at the 0, 0 point. Let's see, we know that our period is 2 pi, so we're going to put that in here. Okay, and we know that the midpoint is pi, and that's going to go up to maximum amplitude through pi, down to minimum amplitude, and stop at 2 pi. It would continue past 2 pi in this same fashion. Now let's take a look at what happens when we have a phase shift. Let's rewrite the equation. Y equals 4 sine, and we'll say pi over 2x. Let's see, is that going to work for us? Let's see. Negative C, so, oh, we didn't put the phase shift. Let's change this. I'm sorry. Let's change this. I don't want to make it too complicated for us to start with. Okay, so let's change this. Excuse me for just a minute. We'll say Y equals 4 sine x plus, this is where I wanted the pi over 2. Lost track of what I was talking about for a minute there. Sorry. Okay, now our phase shift will be negative C over B. So C, we take the negative sign, and C is pi over 2. And then B, in this case, remember that's a 1 in front of there, so that would be 1. Okay, so our phase shift equals a negative pi over 2. Okay, so where is that pi over 2? Well, that pi over 2 is negative, so it's going to start before the 0, 0 at pi over 2. And where is it going to end? This is how we figure out where a phase shift is going to end. It's always the period plus the phase shift. Now in this case, we're going to add a negative phase shift. So our period, remember that's 2 pi plus a negative pi over 2. Now remember, when adding fractions we have to have a least common denominator, so that'll end up 4 pi minus pi equals 3 pi over 2. And we know that point is right here. So our new curve is going to start at pi over 2 and end at 3 pi over 2. It's out of phase. Let's see if we can draw that curve. Okay, so let's see, we're going to come down here. So we're going to go up to maximum amplitude, come down to minimum amplitude, and end at 3 pi over 2. So you see it's out of phase from a normal shift. And this will describe the phase when working with electricity. Alright, let's go on. I think you've got the idea. Okay, here's another one. Let's examine it. First of all, our amplitude. Let's put that down. Come on. Sorry. Our amplitude equals the absolute value of 1.5, which equals 1.5. Now remember, if there's no number in front of the x, it's considered a 1. So our period, if you remember from the previous video, equals 2 pi divided by 1. So our period is 2 pi. Now our phase shift, here's the new one. Negative c over b equals phase shift. Okay, so we have c, which is a negative pi over 3 divided by 1. That gives us a phase shift of a positive pi over 3. Now what is that going to mean? That's going to mean that the wave is going to start to the right of the y-axis because it's a positive phase shift. Now we'll go back to that previous video again, and we will find the first point so we can start to identify these. And remember that it was the period, which is 2 pi, times 1/4, because we want the first quarter, we want the quarter distance to the end, 1/4, plus pi over 3. Okay, so let me do that again. It is always the period plus the phase shift. Okay, And then we use our 1/4, our 1/2, and our 3/4 to determine the 4 points on the graph. So what do we have here? Let's finish this up. That would be pi over 2 plus pi over 3. Oh, already we fall into this. Remember that when we're adding fractions, we have to find the least common denominator. So in this case, the least common denominator would be 6. We have to multiply this by 3 pi plus 2 pi over 6. We're going to run out of room here. Equals 5 pi over 6. Okay, now the half point, mid, we'll call that mid, okay? All right, we're going to take 2 pi again. This time we want the half point, and we need to add the phase shift. So it's the period times the factor plus the phase shift. So what do we have here? Pi plus pi over 3, least common denominator, gives us 3 pi plus pi would give us 4 pi over 3. Okay, and that's going to be our midpoint. So let's just label this. The first point is going to be pi over 3. That's where we're going to start our graph. It's out of phase. Our midpoint is going to be 4 pi over 3. Our quarter point would be 5 pi over 6. And we'll stop at our 3/4 point, and we'll just figure out that end point since I'm running quickly out of room. Okay, so end point. That's the period, and our period was 2 pi plus the phase shift. So 2 pi plus pi over 3, that least common denominator thing again, gives us 6 pi plus pi over 3, which equals 7 pi over 3. That is our end point. So let's put that in. Let's see, that would be this one. 7 pi over 3. Let's put our amplitude in. 1.5, negative 1.5. And let's see what we can do about this graph. Okay, we're going to start here. Now remember, the cosine graph starts at minimum or maximum amplitude. So this is a positive amplitude, so we're going to start right up here. Okay. And then let's see, this we said was our midpoint. So we're going to come down through here, minimum amplitude, up, and complete our curve. Okay, now we can put a little fanciness in there if we'd like to show what happens between 0 and pi over 3. Okay, but basically, again, this shows that the curve starts out of phase by pi over 3. All right, I think you're getting the hang of it. Let's try another one. have 8 sine 3.5x minus 90. Notice at this point that this particular one is not in radians, or we can put it into radians. What is 90 degrees in radians? Do you remember back to that circle and what we said 90 degrees was equal to? That was pi over 2. Alright, so that's what we'll work with. Now, let's see, our amplitude is 8. Our period, I'm going to try and write a little smaller so we get everything in this time, is 2 pi, it's always 2 pi, over, that's a little strange, 3.5. So what does that give us? We can change that into an equivalent fraction of 4 pi over 7. That's a little easier to work with. Now, let's figure out our phase shift. Okay, we'll remind ourselves that that's negative c over b. Negative c, we keep the negative sign, and we've got a negative pi over 2 over 3.5. Okay, now this 3.5 is the same thing as saying 3.5 over 1. And what do we do when there is a fraction in the denominator? We inverse it. Multiply and inverse. So first of all, we'll correct this, and we'll take it to a plus pi over 2, and then we will invert it, 1 over 3.5, and what that gives us is pi over 7. So that is our endpoint. Now let's see, should we do the, yeah, we might as well, let's see, the quarter point. Okay, quarter point. Let's see how tied up we get here. That's the period plus the phase shift. So our period is 4 pi over 7 times 1/4 plus the phase shift, pi over 7. So to simplify this, the 4's cancel out. We'll end up with pi over 7, whoops, that's a 7, plus pi over 7, giving us 2 pi over 7. Okay. That's our quarter point. And then our half point is our original period, 4 pi over 7, come on, 7, times 1/2 plus our phase shift. Okay, simplification again gives us 2 pi over 7 plus pi over 7 equals 3 pi over 7. Let's keep going. Our 3/4 point equals the period 4 pi over 7 times 3/4 plus the phase shift. Okay, let me see if I can do the simplification here. We'll have 3 pi over 7 plus pi over 7 gives us 4 pi over 7. the endpoint. We got that so far? Let's take the endpoint. Our endpoint is the period, 4 pi over 7, plus the phase shift, which is pi over 7. So what we end up with is 5 pi over 7. Now let's see if we can put this into our graph. First of all, it is a positive phase shift. So we're going to name that first point as pi over 7. And what was our quarter point? 2 pi over 7 and 3 pi over 7 and 4 pi over 7, and we're going to end at 5 pi over 7. Boy, that came out a lot easier than what we started, didn't it? All right, let's get our graph. We're going to start at pi over 7. It's a sine graph, so it's going to start on the 0, 0. Oh, we didn't put in our amplitude. Let me go back and do that. Okay, now we're ready. This will be our midpoint, and this will be our endpoint. We're drawing a sine graph, so let's see if we can get this in here. Max amplitude, crossover, min amplitude, and complete the curve. Again, we can complete this by just drawing a dotted line. Alright, so in this case, we were a little different here. We used the degrees. Just convert that degrees to radians, and you could still work the problem. Alright, I hope this gives you enough to work on one on your own. Here's another problem. This one, stop the video and work this on your own. Then when you think you've got it, check it against the answer in the information tab. Remember that your period will be 2 pi divided by 2, and your phase shift will be negative pi over 2 over 2. Now that'll be 2 over 1. Okay, so you're going to have a negative phase shift. That means you're going to start back here. All right, go ahead and try it. This is the end of this video. Thank you very much.